So if you want to find bugs in your app, you can scan the code using static analysis, but it's also really good to test the app itself, whatever is deployed in staging or production, because there's many reasons a vulnerability might be in the app, but can't be found by just looking at the code. For example, you could be deploying like a different version of the app, or the vulnerability could be introduced by a dependency or a configuration that's outside of the repo you're scanning. So we have ways to scan what's actually deployed, and Philippe here has been working on some of that.
Hi there. Yeah, indeed. I've been working on AI pentest for a while now. I started, I think, around a year and a few months already. Joined Aikido to continue there I've been there for 8 months now. I've been with my team as AI pentest leads, mostly working on the technical side of it and making the agents do the hacking.
Very cool. And so you're going to talk about what you've been working on. And I think it's very interesting because it's all like new and evolving. But before we talk about AI pen testing, we want to talk about a little bit of the state of the industry that led to AI pen testing.
Mhm.
So first, traditionally, if you wanted to test a web app, you use DAST or dynamic application security testing, and those are basically web app scanners and crawlers. So you have like OWASP Zap, or it's not OWASP Zap, it's Checkmarks Zap now. Burp Suite has a scanner, Tenable has one. I think Aikido, you mentioned, had a DAST tool as well. And I want to cover a little bit about some of the advantages and some of the challenges of those, so that we better understand what advantages and challenges AI pen testing has in contrast.
Yeah. So I think among the pros, the best one I think right now is the ratio between the amount, the volume that you can scan and the price of it, right? Like it's basically running codes that's going to be run the same way that you can run 24/7 on all of your websites. And it's just HTTP requests that are sent, right? The cost is like once you have the license for Dust, it's about the electricity that you use and maybe network traffic that is being generated, right? It's very much scalable in terms of the amounts that you can scan. The second one, I think, is also about determinism, right? If you do the scan once and you do a second time, you should know what to expect, right? It's something that is predictable, and you're not going to have surprises or maybe issues that are only found 50% of the time. It's either you find it or it's not, it's not detectable by the dust, right? And I think these two are the ones that's really allowed it to go very far so far. And what allows companies to very easily just set it up and get going quite easily.
Yeah, I completely agree. These are great points. And for example, Zap is free, so you can even deploy it as a GitHub action in a repo and run on a schedule, and that's it. Like it takes a short amount of time to deploy. Like the basic version, you can run it forever, without paying anything other than like the GitHub action runner cost. So these are great points. Now there are some pretty big cons to those. I think there's a reason DAST tools are quite hated in general. They don't have a good reputation.
But that's fair, absolutely. I mean, they're limited by whatever code is present, right? In the end, Dust is just doing its best efforts with the capabilities it has to find the vulnerabilities, but the best efforts are really just a very, very big checklist of like attempts to do, right? So you can provide some context to the Dust, right? You can help it adapt to some situation. For example, if you go on the websites, the login panel can be different in different websites. It's actually very often different in every website that it encounters. The Dust will be able to dynamically see the fields that are here, but and test them, right? But the issue is that it can only detect maybe the forms if it uses the HTML form tag, right? And maybe it's actually another HTML tag that is used and it suddenly breaks because it's not able to log in anymore. And if a Dast is not able to log in, well, it's stuck at the very first step and it cannot test any of the features that are actually interesting, right? Maybe you can have some headers as well, but if the header actually has a refresh token that it has to use to refresh a JWT every 20 minutes or so, well, again, after 10 minutes, the Dast is broken and you cannot use it anymore and you cannot find the issues, right? And basically, you can always try to find some workarounds to make it work on the setups you have, but you're always going to be limited by whatever is fundamentally supported by the Dast, and sometimes that's not enough for some situations.
Yeah, definitely. That's I think a challenge I've seen with many companies. They're like, oh, let's set up DAST, and some of them they just like set it up without authentication and just hitting the login page and like, yeah, we have DAST for scanning. It's like, well, you have to figure out how to get it to authenticate. Like, big big part of it giving you value.
Yeah, yeah. And the
Um,
second one, I think, is also, besides the adapting to the authentication part, is also adapting to what issues are you looking for, right?
mm,
A DAST will always try the XSS and SQLi and LFI payloads at the same place every time. Those are basically the same payloads can be used on 90% of the cases. So like that's fine. These issues can be usually found by DAST, and like that's where they excel actually, right? Maybe they still are not able to find the very complex CLI that are second order and require
mhm,
multi steps for it. But generally speaking, it's good at finding these technical issues. Now, if you look at the logic issues, the ones that are more very specific to the business, for example, bypassing a paywall or being able to escalate the privileges of your accounts,
mhm.
and suddenly it breaks because it doesn't
Yeah.
understand what an admin account is versus a member account is,
Right.
doesn't
Right.
understand what tenant isolation is or sensitive data among the user information. So all of those are unfortunately not really, let's say, predictable in terms of what type of attacks you should do and what is the criteria that defines whether the attack was successful or not.
Yeah, that's a really good point. I mean, that's also a challenge even for like pen tester as a human. Like if someone gives you access to the app and you want to try like cross account or like cross role like authorization like violations, and it's not always easy to determine like am I supposed to be doing this or not. Sometimes you just gotta ask the build like the developers because like you
Mm,
don't have enough context to tell if this is an action that you're supposed to be able to take or not. And so
mm,
obviously DAS will not have that context and wouldn't be able to tell if
mm.
there's a violation of permissions. And I think the last one is like if it's just high false positive rate, they have a tendency to flag a lot of things that like you don't really care about.
That's indeed, I think, the deal breaker for many is that you will end up being drowned and you have to search for the one issue that's actually relevant. You don't even know if there's one, so you maybe just are looking into 100 different issues that are in the end just going to make you waste the precious time that you have.
Yeah, so that's you're trying to automate those tests. Now, on the other hand, you can hire actual pen testers, and here
Mm.
like you're hiring a company outsourced or in house. It could be right, but it's a
Yeah.
human actually coming in and testing your app, right?
Mm.
So here, I mean, it's a human, so they have context, at least more context than automated scanner.
Yeah, indeed. Usually you will have some interaction, maybe a scoping call between the customer and the pen tester. And at the end, like you get the information about what the target is, what's maybe is the resources that you get. Maybe it's a white box pen test and you get the code base as well, right? And you can actually explore it and do this mix between looking at what the code base contains for maybe leads of potential features to test, maybe vulnerabilities, suspicions that you want to test on the application. And from there, do the dynamic part, the validation of checking, hey, is this working, or is this maybe blocked by some upstream proxy that blocks these requests. So it's always interesting to have this combination, because instead of blindly testing every attacks, the human can actually make sense of where the application is most susceptible to be vulnerable.
Those are really good. Yeah, yeah, very good points. And then the cons, I mean, pen testing has a lot of cons. Like it's usually related to the price. I mean, if I can have an unlimited ongoing pen test continuously running all the time, that would be amazing. But
Yeah, a
because of the
Dust is a
price, you
bit
have
cheaper compared to a pen test that runs 24/7 indeed. And
yeah,
the thing is that the price is mostly because of the amount of time spent. Because of the price, we actually also limit how often we run it, right? That's, I think, a big issue, is that going for a pen test means that if you do it only every two months, you are going to have, well, the code that is shipped the day after that is going to be left unchecked for two
mm-hmm,
entire months.
mm-hmm, mm-hmm,
Maybe
mm-hmm,
that's fine for some, but for many organizations, ideally, they would make sure that they're safe from day one and not from day 60.
mm-hmm, mm-hmm. Yeah, these are great. Yeah. So this gives us some context to go into the thing you've been working on, which is AI pen testing. And so you've been building a whole platform for that, and you recently gave a talk around that as well.
Yeah, that's correct. I was in Vilnius, great conference called CyberWiseCon. They invited me to talk about the challenges we faced while building the AI agents. And, you know, well, we're a commercial company. We were like, at first we didn't want to share those, but it's already been months. And like now we see this development where you can see this interest in AI agents on how can you use them to secure your code? How do you use them to have these agents do the hacking for you and test your features? And I think this problems are technically very interesting for many people, not just the ones that are creating these platforms. So that's why I presented this talk, is because I wanted to share these challenges that we faced, how we approached the issues we had, and potentially help other companies to have these agents get secure, and maybe understand as well better what's the hype part of it, what's the actual efficiency part of it, why it works, why it doesn't sometimes. So that was the goal of this talk here. So yeah, the talk was mostly going through how the agents that are doing the AI pen test are working, how they're going to hack the websites, how they behave during it, and the challenges we faced while building them. So yeah, the first part is about how the agents are actually working on these targets. And the very first step for these agents is to understand what do they need to attack, right? What are the different places that they need to try payloads on and try to find vulnerabilities in, right? And well, you have two paths, right? Either you do the white box part. White box is when the customer provides the codes, the code base to help the agents figure out what are the best ways to do the hacking. Sometimes code bases have 3 million lines of code. That's the example of OpenClaw here. It's going to be hard if you just give the whole code base to Claude Code and ask it to find all of the vulnerabilities, right? Because if you want to go in depth in every features that you want to test, you actually need to spawn multiple agents that are going to work in parallel so they can each go in depth for testing their feature, right? So we need a dispatching strategy, and then give each of these agents that you dispatched the classic usual tools for agentic exploration of the code, right? Allowing them to understand the codes by reading the files, listing the file, grub, blob. All of those are very classic agent tools. You can see them in different IDEs or agentic coding tooling. Now for black box, it's a bit different because you don't have the code that allows you to see all of the features that are present in the code, right? Black box is different because you only have the target, the URL of the target, but you don't know what API endpoints are. Maybe the customer provided the file, in which case you can do a similar strategy as before of dispatching. But if the customer doesn't let you know what are the different endpoints and only gives you this target link that then the agents have to hack, you need to have a different approach if you want to have this dispatching strategy. And
I mean, that's also a real challenge. There's organizations that have web apps deployed and they don't know what they are. You know, it's like we only have this URL. We don't actually have any more context other than just the URL on what's supposed to be, how it's supposed to work. And so that is a real problem. Ideally, like they'll just give you like more context, and I think like that's an exercise that like everyone should try. It's like, let's actually try to have a markdown file like listing all of the context that I would give an agent to describe what this web app is, but sometimes that's just impossible, I think.
Yeah, indeed. It depends of the security maturity of the companies as well, right? Maybe enterprises have a better attack surface management, but the ones that just want to go fast and ship without being slowed down by security, maybe they didn't do these steps, which is understandable, honestly, right? In the end, it creates a lot of friction when you have to go through all of those. So black box is sometimes easier because you, in theory, don't really have to take care of those. Performances will take a hit, unfortunately, right? The less context you provide to those, the least, like it's both for the agents and both for the human pen testers, more context equals more targeted attacks and less just brute forcing every potential attacks possible, right? But it's sometimes still relevant to the black box. It's easier. It's going to be faster. Maybe sometimes you don't have to go through legal arrangements to do it as well for the big enterprises. Many reasons why black box is still used today, and we understand it. We don't want to fight against it. We still want to secure the ones that cannot allow themselves to go in.
Yeah.
But yeah, for the agents to map these features and do this dispatching, we actually provide them with a browser, right? A browser where they can click and interact with all of the features. And if you give these agents capabilities to interact with all of the features and capture the network while they're interacting, filling every form, clicking every buttons, you actually get a list of all of the requests that were sent. And once you have get this list, you can actually map what are all of the endpoints that were accessed during the testing, right? Or what are all of the passes, and then you can get an idea of what's the
for now, this is kind of like just like having a web crawler, just like click every link and try to like interact with every endpoint, right? Like for now, this is like nothing new.
Yeah. I mean, the good part about the agentic is allowing them to also do the multi-step harder, filling the forms that are like require maybe a valid password that has to be released at the right time, or like filling a 2FA form as well. That's a common one that we see. I think that's allowing them to give more capabilities than just clicking every buttons, but also maybe checking their email for the password resets email that they receive that they want to interact with.
Oh,
That allows them
nice.
to do much more than just clicking every buttons. Then the second part, the fun one about exploitation, is going to be once you have all of the lists of what you want to hack, you can just dispatch agents on them, right? You have one agent or multiple agents work and go in depth on every endpoint that you saw, or maybe every source, like in the code as well. You can see all of the endpoints as well, the sources. Where can you actually affect the application with your user input, right?
Hmm.
And once you've mapped all of those, you can have agents be dispatched on all of those and go check in depth for that.
And this flow right here is very similar to how you would do a real pen test, because
That's
like on the
correct. That's
first
true.
day of
That's
a pen
true.
test, you're just clicking around, you're just
Yeah.
exploring the app, you're like going through the
Mm.
password reset flow, checking your email, right? Like, so this is actually how a pen test works. Like the first day clicking around, then you start like actually trying to exploit what you found in your like burp log history or whatever.
Yeah, yeah. No, that's indeed like there's this philosophy that we had while building a pen test is usually if you had an army of humans that you could dispatch on a target, how would you do it? What would be the most
Nice.
efficient way of doing it? And usually this how will the human will do it, and that's something that's helped us a lot during the development of this
Hmm.
this project. But that's something we can actually see later on when we're going to talk about the challenges and how we solve them. This aspect is going to come back. So yeah, the next step after the next step, the exploitation part. You might be wondering, okay, what are the agents looking for? There's so many issues types that they can find, either SQL, IRC, all of those, and yeah, like how do you have them find those, right? Well, you can actually separate them in different type of issues, right? You have the technical issues. That's the ones that we mentioned where the DAST already perform pretty well. Everything that can be like done within like the same kind of payloads, which is SQL injection. You do the single quote or sleep on and sleep.
Hmm.
For maybe LFI, you do the dot slash TC password.
Hmm.
All of those technical issues, they end up being verifiable because they're the same on all of the web application. If you can read a file with an LFI on an application, well, you can read etc password. And if you do it on another application, well, you can also read etc password, right? So like there's way to verify whether these are real or not. And it's always the same ones. Now, the more logic issues, I mean, you could call it differently, I think, but that's like something that's I consider when I'm talking about the more business specific issues, application specific issues that are not universal. The ones that are going to be specific to how the login page of the application works, because every
Yeah.
login pages are different again.
You need
Right?
like a good understanding of the app itself to be able
Mm,
to determine those.
exactly. Yeah, you have to first reason about it, and then you can actually exploit it. That can also be about paywalls, right? So if you can bypass the paywall, or if you have different privileges and you have maybe a low privilege account, the agent can check,
Right.
hey, can I make it admin? And then, well, that's again something that's very application specific. Now, the hardening checks, I think that's more of a security hygiene, right? I'm
Hmm.
making sure that you use the right security header, that you have a CSP in place. And these are just like you can have it already on the previous. Like that's not AI pen test specific, but that's also
Like
part
the
of what the pen test has, right?
Yeah, I mean, just the normal DAST scanners usually they mostly find these and
Yeah,
nothing
yeah,
else.
yeah.
Like 90% of their findings are like
I think
old
there's still
TLS or
technical issues that are found sometimes, right? Like that's the
it
goal in
can.
the end. But indeed, hardening
Yeah,
checks, like that's the ones that's like code is good at it because you make sure that these are always checked for, and then you can have them always reported. So I think that's
hmm,
that's something we integrated, not from the AA part of it, but just because it's good to have it in the report.
yeah. I mean, they're for compliance. Like
Yeah,
they
yeah.
always really want you to find those. So
Yeah,
yeah,
it's always going to be like lows or mediums, maybe
right.
informative as well, right? But
Hmm.
it's still nice to have them. Now, there's another interesting type of issue that we often notice is the fixes bypasses. Oftentimes, when a user wants to patch an issue and ship it, well, it's always good to retest whether the patch is actually working or not. And the agents can just test the same attack, see if it was patched. A more interesting approach is also have them try to bypass the new fix, right? See if you can actually maybe think of a way to go around what was supposed to be the mitigation and actually go back to exploiting the same issue by finding another path maybe to it,
Hmm.
right? So that's also something that the agents can find quite often. And now, once you have these issue types, your goal is to have as many agents as possible to try every potential attacks on every features, right? Ideally, with the code, it's even more targeted than black box, but especially for black box, it's important that you have enough agents that can actually try and run their own scripts, their own attacks on every features that they can find. And then again, it's like 400 agents. The goal is that they can actually interact with the application, that they can run these exploit scripts. So we can give them every single agents. We can also give them their own machine, their own sandbox, and that
Yeah.
allows them to actually do the dynamic parts, the pen testing part of the pen test, right? To do the exploitation by running scripts, so like payloads via Bash or Python, or via the browser directly. If it's an XSS, you can just use the browser, see if you can get an XSS executed, right?
And the first challenge I think about here is like this is basically approaching the realm of fuzzing. It's like the big challenge is really the cost, because like I can parallelize like 1 billion agents with like 1 billion computing years of like continuously testing the app, but then that's the first limitation. But I did think like, do you think this is something that like local models, like models like hosted locally that are cheap to run, are good at? Do you really benefit way more from the like frontier models?
Well, in this specific example, this is a very basic attack, right? You're going to try different payloads on a certain parameter that was used on the static thing. That's almost something that the DAST can already do by itself, right? Here you can just see that the agent adapted with the right content type. For some reason, I'm not sure what was the issue here, but they had to use the right content type for the specific endpoints and try different payloads, right? But that's very easy, right? Every models that are in the last 2 years that are not that are like that were frontier at some points, they can do it quite easily. Now, the good part about it is that well, by doing these dynamic validation parts, you can actually again see the results themselves, right? If you can read a file, well, read it and see if you get the outputs and actually validate the issue, right? Now, this testing is also again like quite basic, and that can also validate the issue. So like that's really the basic checks. And now the interesting part as well is that once the issues were found, like, and you validate them, you can actually mix the formal validation and the agentic testing part, right? If you can read the file and you get the output, you can actually see whether the output is really here or not. And that's like all of the technical bugs, no hallucination. That's like very like much easier to do. Now there's going to be another parts for the validation. Right, I'm going to go back here. Now for the logic issues, it's going to be more interesting, right? Because previously we saw some stuff that can accomplish, and this is like pretty basic. But we already saw that the flow of the DAST is that it cannot find the logic issues that are very business specific. So how does AI pen test? And most importantly, how do we make sure that these are valid and not hallucinations, right? Well, first, we have to kind of categorize and separate these technical issues, right? Technical issues, if we can validate them, let's reduce the noise as much as we can already. Now, we don't want to restrict it to the technical issues. We also want the logic issues whenever we can. And that's going to be about the missing authorization, the sensitive data exposure. And that's actually the majority of the issues that we're finding. It's going to be these checks that are very business specific. So the good part is that they can actually verify it by testing it live, right? And it's not going to just check, for example, if there's a 4.3 unauthorized when you put another ID, right? Ideally, the full reproduction of whether another is real is, can you read the data of other users? But at the same time, you don't want the agents to read the customer data as well, right? So what an agent could do here is to have 2 different accounts, and we actually recommend to provide 2 different credential sets. Have one account creates maybe, in that case, it was a node, so it creates a private node. And then the second account checks whether it can access this node that was created, right? So
which is
actually
also
verify
what
dynamically.
a real pen test would do that. You would have multiple accounts and you would test with them. Nice.
And it's the same. It's not just about cross accounts, but ideally, like the perfect case scenario is that we have 4 accounts, 2 on each in 2 different tenants, and these 2 accounts also have different roles as well, right? And like that's the perfect case, because you can test for cross tenants issues, but also maybe inside the tenants you can still have issues where a member can become admin or a member can read the data of other member while it shouldn't, right? So the perfect scenario is really to reproduce the environment that allows the agents to test everything by themselves and confirm it, basically. So now that we have this base of how you create this approach for an AI pen test, you realize that when you put these products that you work so hard to create in a production environment, you're going to cry, because there's nothing that goes well, right? Have to work on their setup, right? And I'm going to go over the main ones, I think, that were most interesting to go over. So the first one, it's the authentication. So we mentioned that DAST have some issues in authentication, right? It's always going to be a different login page, and the agents themselves, well, they also have to work on those cases, right? So if you do a curl of accounts.google.com, well, the agents cannot from the curl figure out how it would need to log in, right? It will be a
Right.
very, very complex multi-step approach that it will need to take here. And authentication is important, right? Because usually you have 3/4 of the features that you want to test that are behind the authentication wall. So yeah, we have to find a way to support all of these different authentication, right? You may have email, password, you may have the HTTP basic auth as well. You may have like login via third party as well. So the philosophy here again is what a human will do, right? And like it's pretty simple. A human will just use their own browser and log in because like it's the obvious thing to do, right? Well, let's give a browser to the agents then, right? And see how they perform. And it actually worked quite well, right? We're positively surprised how efficient an agent was at using a browser. Now it's a bit more popular already, but at first it was like a year ago, we were like, man, don't know how good it was, right? And now it's even better because it doesn't do misclicks anymore, right? It just fills the form and clicks the right buttons all the times. And it's super impressive to watch it live. Now, you may be wondering, okay, we have 400 agents that need to log in and like they have a browser, cool, they can input username, password. But what happens when you have 400 agents try to log in on the same account at the same time, right? So there's different potential scenarios that could happen from here, right? And I'm going to give 4 of them. Multiple ones are correct, maybe a few are wrong. So the first scenario would be every agents are able to log in successfully, right? They enter username, password, that's what we want, right? The second one is the customer complaints because you have like an email that is being sent every time there's a new login attempt that is being done on the account, right? And then they complain because they have 400 emails or more because some agents also logged out because like they need it sometimes. And they have like 500 emails at the end of the pen test, like they're wondering, what the fuck is happening? Why are you doing this to me? The third one is, IP banned after a 10th attempt, right? Agents, like they try to log in and like they get IP banned because they use the same IP. And the fourth one is the account is locked out because too many authentication attempts and the server doesn't like it. And like it never goes as expected. There's always something going wrong with that, right? It just doesn't work.
Yeah, I mean, like this is like DDoS as a service. Like it's just like like you're DDoSing some of these authentication servers. But also it's an interesting point here is I assume you're running all of these from your own infra, and ideally the client is allow listing all of your infra for this pen test, which is also like an important thing to do during real pen tests.
Yeah, I mean, like that's again this approach of what a human will do, and again, yeah, it's giving the IPs to be whitelisted. It's not just for the account, right? It's sometimes about the different captcha or turnstile systems they have. It can be also about the Cloudflare WAF. That's a very common one. They always have to whitelist for the Cloudflare WAF, so we still get to find the issues because usually, like even if there's a WAF, it's always good to fix the root cause issue and not just a symptom.
Right, and then outside of WAF, some applications do their own rate limiting.
That's true. Yeah. So yeah, we give like this user agent header, of course, but ideally the IP because a user agent can always be spoofed. The IP is much harder for that. And so what would be the solution for this, right? Because you want all of the agents to use the same accounts and don't want to get them banned. And again, let's just think, what would a human do? If you had 400 humans and they all want to do this pen test and they have the same account, but they know there's like a locking mechanism that is likely to happen. Well, I think as a human, I will just have one person log in and then share the cookie or the local storage to the other. So like basically just allow cross-agent communication and collaboration for them to work together and avoid this type of situations, right?
That's a good point.
Yeah, I mean, like that's something we encountered a lot. There's another one that we encountered. This is especially for enterprise applications.
Sorry, just to go back to your previous point, I'm curious, like if you have multiple agents running in a sandbox, how do you get them to talk to each other?
So the way it works is that we have separation, right? We have this sandbox that the agents have that they own the machine, right? They can do whatever they want, like it's RC by design, like it's providing a VPS to the agents or the user if they want to do fun stuff on it as well, right? And then this VPS, it's isolated from the rest of the infra except the API. The API is the only thing they can access. They have their own token for each to access the API. And from there, the API can actually, receive a request of like, oh, hey, this agent wants to communicate this to other agents, right? And then like they have their own unique token to like say, hey, that's you or that's you. And then like you can actually have them communicate together.
Nice. And the API is like the API of your own platform that you built.
That's correct. Yeah. It's great. It's like in the end, our infra is a lot of orchestration around the agent. Like the agent
Right.
itself, of course, we have to give it the right tools, but like in the end, like the model itself is what matters a lot, and then it's going to be the classic agentic tool give it the right capabilities. But I think what's very important here is the whole infrastructure and allowing them to work together efficiently, and like that's also the part where we have them to be able to communicate with each other as well. That's the same thing. It's not just about coordinating for this specific issue, but like that can be reused for other issues, right? If there's an agent that wants to test the password resets, well, the password is different now, right? So you want the other agents to know that, hey, now you should use this password instead. And it's important to communicate those, because otherwise then the agents end up being locked out and they cannot continue testing anymore. Now, internal application, that's also something we encounter a lot for enterprises. That's like something that's gated behind their own network. It's not connected to the internet, but they still want it to test. But our service is on the cloud. It's not just a software that you can run on your own laptop, right? It requires a lot of GPU. It requires a lot of resources as well, because
are you now going to
machines.
install? Are you going to install their like VPN client on every single sandbox you're running?
Yeah, I mean, like in theory, that is not impossible, because we'll see it later. But we can, like, the network is going to be centralized in one place. So we are actually implementing it for 2 customers that we have, but like not like even then, not everyone has a ready OpenVPN connection that they can give to us, right? So we have this VPN support, but we also have like a simpler approach where we can just install a Docker container, and this Docker container is actually going to connect back directly to our services, right? It's not something they have to expose. It's us that are exposed via a public endpoint that they can connect to with their own token, and then it creates this bridge between this Aikido and their own application.
Yeah, which is also something on real pen tests. Sometimes if you want to test their internal network, you just send them like a Raspberry Pi or like a small box that they deploy, and now you have access to their environment. So
yeah,
that's
exactly.
Like
That's really close. In the end, like most of the things we do is like very close to what an army of pen testers would have done in terms of hacking, right? And then besides that, there's like many capabilities that we have to support to be more universal, right? We had customers that ask for 2FA for connection, or that ask for an email. Maybe it's like Magic Link, or if you want to test the reset password as well, right? The reset password is a very interesting feature to test for. And all of those also required email for each different agent, their own email, or each account their own email.
So that's something you implemented. Each agent has an inbox.
Yeah, that's great. So like we have each agent their own inbox, but sometimes, you know, when you create an account that the agents are sharing together, then it's a shared mailbox as well that the agents can check together, and that allows really to have basically a universal setup support for every application. That's what we aim for at this, right? Something that works on every application without having case basis. It's like giving capabilities instead of giving implementations directly, right? There's also phone number support, right? It can be 2FA or like SMS verification when you log in. It can be hosting external payloads as well, right? If you want to test for Log4Shell, which is a very big one, Log4Shell. Well, you need to expose some kind of like you need to expose the payloads that you're hosting to be able to exploit this RC. And if you don't have this feature, well, you're missing a critical 10 on 10 CVE. That's usually is like something you don't want to miss, right? And file upload support also, like that's also part of the browser. When you give a browser to the agents, you have to think that, well, they don't have a whole laptop, they have a browser, right? And this file upload feature is like a mix between a browser and the laptop itself, right? That's like a bridge between the file system and the browser itself. So we had to also implement this bridge itself, because we like maybe eventually we'll give a whole computer to the agents, but right now like it's like a VPS that's headless with a browser, and like we still have to give these capabilities for them to interact with what's usually used in these applications.
And this screenshot reminded me, like, does each agent have its own like persona with like theoretical like PII basically, and would you upload a passport or a driver's license for an agent?
Well, that example is very specific to what we had. It's not real from a customer, it's from Google Image, right? But our customer did ask the agents to do the authentication by uploading an image of their face, actually, right? So every agent had this image like face.png that the customer uploaded. That in their turn the agents could then upload to log into the service. So that's that. Like again, instead of doing a very specific implementation of uploading a face.png at this endpoint, we instead gave the capability to the agents to do it themselves, right?
Nice.
So like this approach is really what allows us to like grow bigger and bigger to what we can test for. And right now, like we got to a point where 99% of the, 95% of the pen test, like it's self-served and you don't even need some like engineering help there.
Mm.
And yeah, like there's much more as well. I think like I would need 5 slides if I wanted to list all of the ones that we had to implement in the end. But again, like we always want to give like maximum capabilities to the agents, right? Now, in terms of the what the customer expects from the product, right now we're selling them something that's basically says, hey, we have an AI hacker that's extremely good and better than whatever you can find out there. And if you pay us, we're going to let it loose on your platform, right? And like it's very scary, of course, right? So we actually had to put some safeguards to make sure that they are not damaging things that they shouldn't. The very first one is that every connection from the agent that is being done goes through a forward proxy that we have, something that will check the destination of the request and is going to check, is it part of the scope or is it out of scope? Are you attacking the targets? Are you accessing a static file? Well, those are fine. But if you're attacking stripe.com because there's a Stripe page on the platform, well, that's bad because suddenly like the agents are doing stuff that they shouldn't. Same for like a staging application, right? Like if they stay on the staging environment, that's fine. If suddenly they start to go on the production one, well, usually it's still fine, but like you still want to avoid this case and taking this risk that the agents do the hacking on the production. Maybe other users could see the payloads that are being used and whatnot, right? So like that's something that's really is restricted and not at the prompt level, not at the trust of the agents level, but really at the programmatic level to make sure that
Nice.
it's not just we ask them not to interact with those, but we prevent them and don't give them the capabilities to interact with what they shouldn't interact with. And if, for example, cal.com, that's another example. If there's a calendar to take a booking on the page, well, it's going to prevent access to the cal.com domain, right? Now, another issue that we faced as well is the fact that there's this training gap, this knowledge gap between when the model was trained, the data of the model, and the present, right? The model is very good at knowing what was the maybe last 20 years techniques, but we're talking about the very, very recent and modern kind of techniques that were discovered. It's not in the training data that was used to train the model. In this example, I used Gemini 3.1 Pro, but the 3.5 Flash that's released in like May, it's also like the same 2025 January. Like that means that there's 1 year and a half of data that the agent just doesn't have and doesn't know about. So we still want them to know about the latest techniques and attacks, right? Especially because they're usually the rising threats that the customer really care about. An example of that is all of the LLM attacks, right? Prompt injection, making sure that the tooling is allowed. And that's something that can be solved with some more manual work where like the human in the loop right now. In our team, we have researchers, we have many hackers in the team actually. Most of us are hackers actually. And well, we have this knowledge ourselves that we can provide to the agents is basically distilling our own data to the agents to help them be the best and know about every techniques that are out there, right? And skill is also something that's like a good practice in terms of the context. We don't want to give maybe these techniques to all of the agents because maybe there's going to be only 1% of the agents that are testing the LLM features. But with the skill, you can actually allow only the 1% to have the context and not pollute the context of the 99 other percent.
Nice.
Now, an interesting point is also checking how a pen test is being launched, right? And there's going to be multiple steps. The first one is obviously what is the target, right? The customer wants to provide the lists that are going to be used by the agents, and then ideally provide more context than just the URL. As we saw before, black box is hard. You have to find yourself all of the features. If you provide the codes directly, well, the agents know what to look for, what attacks to try, and it's going to be much easier for them to find the issues as well, right? And then you can just launch them and observe, do the hacking. That's also pretty fun as well because you can see all of them working in parallel. And at the end, you get the full report of the issues, right? And if you look at this in practice, well, we can actually check what the final product looks like. So in terms of how it looks like on the final side, right? Once we have implemented all of those, well, we have this part here where we have to provide the domain that we want to attack themselves, right? Usually it's going to be maybe front-end and API. We often see it separated. Sometimes it's just one domain. In that case, it is just one. And then you can actually have the interesting part, which is having the users, right? If you have a username password, for example, you can just have the agents go on this page here and like just give it as natural language text as well, right? It's an LLM, it then understands those instructions. You can just say it, go on this page, enter username, ASD, passwords 123. And then, well, this context that you provided is going to, well, give to the LLM, to the agents that has its own browser, and it's going to read it, go on the page here. So it's now navigating to the page. You can actually have the traces of what was they use. You can also have the screenshots of the browser itself. You can see that now it will press login automatically, enter the username, password fields as well, press login. It goes pretty fast, so we didn't see everything. But like you can see that it was able to log in using the browser. And once it completed, well, you can actually, confirm that it was being done, right? And you
Mm-hmm.
can also just see all the request logs that are sent. That's also something we want to make sure that the user can always see what's happening and make sure that see what happened as well in the past. Now, that's the part where you have the safeguards and what's attackable, what's accessible. Everything that's outside of this list is blocked. And then like that's the repositories where you have to where you can list what you want in terms of the repositories. Sometimes it's one monorepo for the web application.
Mm-hmm.
Sometimes it can be 10 microservices. Sometimes it's front and back end. It's very depending on what customers they are, right?
And here, I'm just curious. So I know Aikido has like code scanning tools, right? Here, are you basically handing this off to the code scanning tools and agents, or are you doing like your own analysis here independently?
So when you import the project, it's going to automatically do the basic checks, right? It's going to use the DAST and like you're going to have the issues listed here. But the pen
Okay.
test itself is completely different and it's
Okay,
going
I
to be
see.
fully agentic from A to Z. The reason for that is it's the same as DAST, right? It's usually going to be cheaper to do these deterministic and fast checks, but in the end, nothing beats as anything that's as close as possible to the model itself, which in this case is just giving the code to the agents to figure it out. And now it's going to be another one, which is the throttle. If you want to not break your application, you can put it a bit less than 150 requests per second maximum. We added this. I think there was one time, like we did hundreds of pen tests by this time, right? But one time we actually had the agents send too many requests. So since then we actually implemented this cursor and avoids the agents send more than, let's say, 100 requests per second as well. That's also something we often see like in pen test as well, I think. That's, again, it's a practice that is very common that we want to integrate here. And from there, you can just do the schedule, continue, have the price depend on the size of the code base as well. Bigger code base equals more agents as well. And then you can just start it. And we do ask for staging environments. We know that many customers cannot provide a staging environment, so we ask it, but don't force a staging environment. And we allow the agents to go on there. We cannot guarantee that nothing will be, let's say,
broken.
Yeah, broken. But like we're trying our best, and so far, like again, it did break one time when there was too many requests that were sent. So we still ask for a staging environment. But I think right now the agents are good, like are pretty good, and it's now quite rare that stuff breaks. We still recommend staging because sometimes on production it creates a lot of data, right? You have all of these payloads that are sent, and you have to clean them up if it's on production. Otherwise, you have maybe 100 tickets on support that were created, or 50 registration requests that were created. It's going to take to create some noise, not on the results themselves, but on the application itself. So staging is always, let's say, easier, but production is also like you got to a point where the models know that they shouldn't do risky actions, and we also ask them to do a very minimum impact proof first, right? If they have a SQL injection, they don't check the data of other users. They check either their own or just do like even a sleep to see whether they can actually do it. And then they report the issue. We don't allow them to check for other customers' data or try to see if they can do a reverse shell on the server itself. Just like a small like ID as an execution to see that it works. That's enough for the agents to stop and report the issue. Now that we have the whole product that is ready, an important part of it is just testing it, making sure that what you're doing is working, that your improvements are actually improving the performances and not worsening them as well. And that's something we worked quite a bit on. The very first thing that we wanted to see is like, are we even comparable to human pen testers, right? It doesn't make sense to go on for an AI pen test versus a human pen test. And 6 months ago, we already had like smaller models, but we still did the test already. In terms of time, like obviously a computer is faster than like a human, especially when you have 400 agents working in parallel. So yeah, the agents just do all of the features in parallel. It's just much faster. But time is not the main criteria, right? Usually what people want is, can you find all of the issues? And that's the depth part of it.
Although one thing I'm curious about in comparison of time, like I think time is a weird metric to pick just because it's a measure of level of effort. So, well, the first thing is like you would compare maybe one agent to one human, but then also like how many agent tokens are equivalent to one human day of like 8 hours, right? Like that. Those are metrics that are kind of, but I guess do they even matter because the end user like will get the results of what they see is like parallel agents working at the same time over longer periods. But then I guess the comparison would be, to make the comparison relevant, it would be cost. I guess it would be like, if I had to hire a full-time pen tester for one day, that amount of money, put that in agents, and now I can do a valid comparison. But then even cost is variable for human pen testers. So I guess my point is, like, the comparison is a bit hard to make here, because there's so many variables, including like variable pen test rates.
No, I mean, I agree with you. I think like right now we mostly focused on what we see people are looking for, right? And what we see is that sometimes, well, they have 1 week to get a pen test being done, right? And if you want to give this to, well, a traditional firm, well, you would get either rushed work that they didn't have time to complete, or maybe like extreme fees of like urgency because they have to drop other projects or post them. So like that's still something that we think is relevant, is how fast can they get done with this pen test. Sometimes it's much faster than what they expected, and that's something that's still relevant for them.
But like, assuming the cost is equal or cheaper than a normal pen test. Like,
I mean, that's one of the criteria, cost for sure. I agree. Like, I think it's major. I think right now, like a pen test, we just made it pretty close to a human pen test. I think even a bit cheaper, actually, honestly. But like, we wanted to prioritize performances over like over cost efficiency, because in the end, like the teams already have their budgets. They just want to have the best performances with the budget they have, right?
Yeah.
And then depth is like what actually matters, right? Is how many issues you can find. Like, again, like in average, like the agents were able to find more issues that are like the ones that are leading to RCs and others. Now, in terms of like the compliance, we still like, so humans see more of the like bad, say, patterns that are important for the compliance side of it. It's like the security hygiene that comes back here, right?
Sure.
And I mean, that's something we worked on that like about 6 months ago, so we improved since, like based on the failures. Like, it's always good to compare, like see what are the differences, and then you can always improve it based on like what are the differences. And then like, okay, we got to a point where like we can match or outperform the like traditional level. What about the other agents that do this, right? And like, to test it, we actually created the benchmark application, right? We just put 80 vulnerabilities in this benchmark app, like an actual big application. And then we went over like all of the pen test equivalent that we could find, right? So like Strix, double security agents, Shannon, all of those. And we ran on all of them to see and compare like issues found, but also false positives, right? And it costed a bit because we each had their own model, right? Like Opus 4.6 for Cloud Code and Shannon to go over like a 200 endpoints application. That's like, it's not exactly cheap, right? But it's like comparison that was like we wanted to do and see like where we still have like gaps that we can improve on, right?
And I'm curious, was this over like one scan or an average of findings over multiple scans?
That's an interesting one, because that's true that they're not deterministic, right? So there could be some different results here. We did one scan because like we didn't want to spend additional 20K on it. But like it was just a general idea, like to get on how we were performing, right? And well, I mean, again, like we found like quite some issues and like false positive as well, not a lot. It was very interesting to see that Cloud Code, which is like very bare bone, right? Like it's agents, you give it the tools, and like it can do like the basic action. It's just one agent, right? Well, it still outperform like some repos like Strix, which is like very, very much engineered around it. So like that's something we see where like giving guardrails and like trying to guide the agents and holding its hands, it's really going to be counterproductive, and you end up restricting the performances you could obtain. If, on the other hand, you really use this concept of like leaving it as much as possible close to all of its capabilities that it can have, and maybe like adding new capabilities that it didn't have previously, and maybe also managing them to make sure that they can work in parallel on different features, not restricting them to the feature, but dispatching them for having a different initial focus, right? Well, that's essentially what allows to get better performances, and it's much better than trying to have deterministic workflows, I think.
Very interesting. Very interesting. I am curious though that it is expensive and hard to compare agents because of non-determinism, but also just the token cost, right, is expensive. So I was curious, are there any plans to make this benchmark app public so that other people can use their own and then have like community sourced comparisons?
I mean, we didn't have much incentives to do it open source and to help our competitors, but I mean, if that's something that's like that can be let's say creates more proof, because like that's like essentially right now it's like this is a trusted benchmark, right? This is not something that people can reproduce themselves, so like it's not ideal to prove the performances. So in that sense, it could make sense to open source it so like we can have a fair comparison. Maybe someone else other than us do the comparison. I think that's something that could be helpful as well, right?
That could be interesting. I mean, like, just benchmarking is a whole other conversation we can go into a lot, but like, I always think it's interesting because a lot of vendors pick, for example, OWASP Juice Shop as an example of like an app to test. But then I'm always conflicted around like, is this actually realistic? It's kind of realistic, but it's a bit too contrived because it's a bit too vulnerable. But some people like set it to the like harder levels or like the harder security level and then try to test. So it's just like the whole topic of a benchmark is very interesting to me because it's actually not easy. Like it's hard to find something that would be a fair comparison to everyone. But
No,
I guess
that's
that's
for
part
sure,
of
yeah,
real
yeah.
life, you know. Like also like some agents or the way they're made might be better in some scenarios rather than others. It's just there's never going to be something that's consistently good
Yeah, yeah.
over everything.
And like that's also something that's I saw recently, like on a message from someone like on a like AI hacking community on Discord. He mentioned that he tested the XBO benchmark on the most recent models, and he actually noticed that the models themselves now had data poisoning because the latest ones actually ingested the benchmark itself as part of the training data. So like now even in black box you
Yeah.
cannot test them anymore because they know about the code content.
Yeah, exactly. Yeah, good point. Yeah.
And like that's even more the case for the more like the older you get in the benchmarks, the more usually it's like present and strengthened in training data, right?
Yeah, so you need like so maybe like a bot that auto generates a new app to test, and then that gets tested, and like every time it's like a different app or something. Like
yeah, and like that's actually like what we did later, and like so going back to like comparing with the others, like all of those is like what we could access, right? The open source ones or like the proprietary, but that everyone can just self sign up, right? And now the thing is that there are others that we cannot sign up ourselves because like there's still sales process and like they wouldn't allow the competitor to go through it. And the other point is also that until now we compared with our own benchmark, with our own setup. What about like, but a realistic comparison is having an external party judge themselves, right? And so like that's what we essentially did, right? We asked a third party that was very like independent from ourselves and the things that we wanted to benchmark against, right? And then they selected two applications that they tested on, and they had different criteria, right? They wanted to have it complex enough to be realistic, so like making sure that there's different type of authentication, multiple privileges, but also multiple languages as well, right? And overall, like open source applications that are like very much production-like, right? Real life and and very close to what customers would use and have as targets on a real pen test, right? And so they tested these two repositories on both like the product of Aikido and XBO. I think XBO is like the one that's like made some noise in 2025, and we wanted to compare it against to see what's the current status. And well, there's different criteria that they used. Like previously we used time and depth. They used also other ones. They used the setup process. So like self-serving versus sales process, for example. The speed we already had. Testing process is an interesting one, right? That's the things we mentioned before. It's about will the agents log their own accounts out, right? Will they clean up their own payloads once they're done testing?
Oh, okay.
And that's like the things that's making sure that, hey, the pen test is going well and doesn't break mid pen test, but also that's after the pen test, you have everything that's like fine and you don't have to work to clean up behind them, for example, right? That's the depth itself, like it's finding more or less issues. False positive, I think like we did a good job, both of us, right? Like Aikido and XBO 1 and 2 false positives, like that's pretty nice.
Amazing for both. Yeah.
Like there's this thing where like people still have like automated equals DAST equals high false positives, but with the verification part, well, we get to a point where like we have pretty good numbers now, I think. And then the severity assessment, I think that's an interesting one because it's a bit arbitrary, right? It's like severity, whether you see, like even if you use like CVSS, which is a standardized format, like it's always going to be different opinions for different people.
Definitely.
And then the reporting itself, it's about like okay, you get the issues, how actionable they are, right? The source, where's the issue, how do you fix it, etc., etc.
Yeah.
And I mean, again, we were able to like get the numbers that we wanted in terms of the performances, but this is like only the issues we saw, right? And there's this thing where like when you do a pen test, you don't know what you missed, and like it's pretty hard because you most likely are missing issues, right? And you would want to know which one they were, right? And well, there's this CVE dataset. Well, every month there are like thousands of CVEs that go out, right? Like vulnerabilities in open source software, sometimes not open source, but many of them are open source.
Yeah.
And there's like thousands of them every month, right? So like even if you want to have the ones that are like after the training data of the model, so like maybe in the last 6 months, we still have like 6,000 CVEs that you can use for like testing stuff on, right? And like the goal here is like, can we find 100% of the CVEs again? Can the agents without the context of the CVE and in the vulnerable version find the CVE again? And try to improve it and see when it can't, and make sure that next time it tries, well, it's able to. And the one issue with that is that there's still this issue where like you don't have 100% of the issues there, right? CVEs are only the issues that were found by other people and reported by other people. But maybe until now there's like this 50% issues that no one ever found, and we don't want to optimize to only find the 51st%. We also want the 50% that was never found by anyone, right?
Yeah. I don't know, but like, will an agent ever reach the ability of finding 100% of all possible? I don't know. I don't even know if that's possible. I mean, maybe if you it's the same with fuzzing. If you give it like unlimited computing, like 10 billion light years of compute, like maybe eventually you find you converge close to 100%.
It's like the monkey and the typewriters, you know, if you give enough
yeah, infinite monkey theorem. No, exactly. Yeah, no, it's kind of like that. I feel like it's impossible to get 100%.
But it's like I think for like formal proof verification would be the only way, but like that's not applicable in real life. I feel like
right, exactly. It's like not realistic, not practical.
Yeah. So I think again we can get as close as possible to the 100%, but 100 like actual 100% is maybe idealistic, I think.
Yeah, I think so.
But yeah, like anyway, the next goal is like to find this 50% no one found until now, right? And well, we actually first have this data set of like not only the open source application, but the customers that do the pen test themselves, right? Like we're able to like see what the agents are finding on the pen test themselves, and quite a few times we found issues that previous pen test missed. So like that was also interesting to see. It's like good to compare beyond what was known as issues. And then there's like in open source as well, where we found quite some issues. There was like Svelte kits, for example, Codify, LangFuse, N810, Astro, Storybook. And like basically every time we scan the repository, we always found like a new issue and CVE that we reported. We often do blog posts about them as well. But like the problem is that now there's this imbalance, because every time we scan a new repository, we always find like some issues that we want to report. We only have a few researchers in the team that can report all of those. On the other hand, there's also the maintainers that receive many reports from our side and have to deal with through them, because there's not only the Aikido reports, there's other ones that report the CVEs.
Yeah.
It's hard for them to like do all of this work to defend. And like I guess AI can also be used for creating the patch, but that doesn't mean that like it removes like all of the work, right? You still need like the humans to review it. The maintainers still have to go through them and make sure that it's not like slop, right? And like it's a lot of work. So it's still good if we can help the defenders like by providing them guidance as well on like the root cause, trying to be as detailed as possible. One thing that is also often useful is providing a poke. So like a script you can run and verify that the issue is real, and you don't have to like go yourself through it to try to understand. Like you just have a script.
That to me like AI being able to provide a POC, because like sometimes the developers will argue with you like, I don't think this is exploitable, but then like here's how you reproduce it, like 100% confidence, like just click or like run this command and you'll see that it's exploitable. Like that really helps convince people that it's worth fixing.
Yeah, I think they receive a lot of false positive as well, right? And like they don't want to waste time on it. So providing a poke is like instantly triaged, right? Basically.
Exactly. Yeah.
And like providing help on like how to fix the issues is also often appreciated. Having a human go through it as well to verify it as a second layer, it's also something that can like give more reassurance. We don't want to like automate the issue creation. That's like it's maybe too risky in terms of like how much noise it can create. So we still have like people that will create a more detailed approach, maybe screenshots as well, video reproduction, to help the maintainer have a high quality report that's like actually worked on for a bit. But the issue is that like we find more issues that we have the capacity to report them, and like it's pretty hard to like secure everything when we have a small team, honestly. But we're trying our best. Like we basically aim for like the big repositories, right? The one that have more than 50K stars that impact as much people as possible. I think that's like it makes sense, because if you have limited resources, might as well have the biggest impact with those. In the end, like that's like something we noticed. Like okay, now we're in a time where like issues are much easier to find with AI and like at a scale. And it's not just like creativity or no creativity from the AI. Like as of now, it finds more issues, even the multi-step complex ones. That's like pretty it's like right now we're in a period where like large scale hacking is not unrealistic, and it's good to have the AI also on the defender side, not
Yeah.
just the attacker side.
Yeah, definitely, definitely. Yeah, I mean, all of the system you described to find books, like eventually people will build similar systems to help patch bugs, right? The same way you can generate a POC. From that, you can, kind of like trace through the code and see which part of the code the vulnerability exists in, and have a working patch for that and validate that. So, I mean, it is also a lot of work, but I imagine eventually we'll get there as well.
Yeah, I mean, like that's also what we wanted to do here, right? Like in terms
Oh, nice.
of helping the user, is like, well, we have AI find the issue, like as you mentioned, you can also find a way to
Yeah.
fix the issue, right? It's like that only works for white box. However, for black box, you cannot provide
Obviously,
a code
obviously.
patch because there's no
Yeah,
codes
yeah.
to patch
Yeah,
here.
obviously, yeah, yeah.
But for
Yeah.
white box, there's like this view auto fix button. You can click it, and like, yeah, you can create a PR quite easily. And like that's the private note without check that we saw earlier. It's like adding a check, and like that's a logic issue and not a technical issue. So like
Yeah.
it's actually relevant that it's AI and not something that's like autocomplete, change a function for another one. It's something where it's like it makes sense to understand what the issue is and actually fix it properly.
Okay, so that was an awesome presentation. I think you covered a lot of like super good insight. So I wanted just to finish it up by adding some of the context here, comparing AI pen testing with traditional pen testing and just normal DAST. So I think that the obvious one is it has, I'm gonna call it context aware, but you can give it like real context that a human would understand, right?
Yeah, I mean that's exactly it, right? Like it's natural language instead of like programmatic checks, right? So you can give them, for example, instructions on how to log in. You can give them a more like if you give it the code, it will actually go and understand the code, not just like look for patterns as well. And that allows them to like really interact with everything and test all of the things that other people would consider as being issues. It would also understand this like kind of threat model in the end, right? And with this model aspects, it can like go and find these complex authorization issues that previous DAST couldn't find. The other thing is that because you have that many agents in parallel, you can really have them work in depth, each of them. Sometimes multiple agents on the same aspect as well. We see that sometimes it helps to have multiple pairs of eyes. And you're leaving basically nothing unchecked with this amount. Like with enough agents, it's not just like the quantity is actually becoming quality, right? Because you have everything being checked in depth, and you actually can really basically, with smart enough models, of course, find all of the issues that's, well, you would be able to find by reading the code manually.
Definitely, yeah, yeah, yeah. And then downsides,
Yeah, I
definitely
mean that
cost.
downsides, yeah, like the cost is going to be more expensive than Dust for sure. Like it's going to be agents that are like 400 agents that are running for like many steps. So it's going to, like, the more the step increase, the more there's going to be a bigger context and more tokens that are going to be used. In the end, like we still aimed for something that's a bit under the existing pentest budget. So like you don't have to increase it to get it to work, and you can reuse this budget for a pentest, but it's still something that's more expensive than Dust, that's for sure.
Yeah, usually people will just pay as much as they would pay for a pen test. Oh, I mean, but not necessarily though. It depends on each company. So I'm just gonna leave
Yeah,
that
yeah,
out.
that's for sure. Yeah, yeah.
And then, so the non-determinism that's maybe compared to a DAST, but I would say that a normal pen test also has unpredictability. So I think this is not unique to like a normal pen test. It depends on the pen tester you get,
Yeah,
and then, like,
that's
are they
true.
having a good day? Are they,
Yeah, yeah.
like
You
maybe.
don't want a junior to pen test the bank, for example, right? But also,
Sure, yeah,
yeah,
yeah, yeah. So
as you're saying, it's like also depending on like we're only human, we cannot be perfect. Like that's fine. It's just that like it implies that there's like indeed sometimes some stuff that is missed.
yeah,
But yeah, indeed, like it's the same for a pen test, right? The agents sometimes are going to go into rabbit holes that they shouldn't, or sometimes they go into rabbit holes that
right,
end up being an issue.
right,
But like
right.
it's going to not be different. There's going to be sometimes different as well, and that's something also we noticed. Like another reason we're doing all of these agents is because we can kind of fix this, like not fix, but mitigate the unpredictability by having multiple agents look at different things, right? So if
Yeah.
one is like misunderstanding something, well, the other is likely to understand it anyway, right?
Like the more you parallelize, the more you increase coverage and predictability over it.
Yeah, that's correct.
Like if you have infinite agents, I like probably it's gonna find close to everything, but not
Indeed.
actually everything.
Yeah, yeah.
Interesting. Cool. Anything else?
Yeah, I mean, in terms of the cons, like it does require more setup than like a DAST, right? Like you might need to configure different accounts.
I mean,
You might.
yeah, you say that though, but it seemed pretty simple. Like maybe slightly more than DAST, but in a good way because DAST people just like under configure it, you know, like they
Okay,
or
fair
they
enough.
just don't set up
Fair enough.
auth.
Fair enough.
You know,
That's
it's
true.
like oh, just hitting the login page. It's like um,
Mm.
it's I would say the same setup as a pen test.
Yeah, no, that's fair enough. That's true. That's true.
More setup than DAST, but similar to pentest setup.
Mm.
But things like yeah, like setting up an inbox for each agent. I mean, it depends. If your platform handles it, then it's not a cost to me. It's a cost to the platform. But
Mm.
if you have a framework to automate that, then it's not too bad.
Yeah, 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 for sure.
Cool. Yeah, this was awesome. I feel like now I have a better idea of how to or of what AI pen testing is.
Glad to hear that. I'm happy I could help with that. Yeah, I mean, thanks for the invitation. Honestly, I loved sharing all of these challenges and maybe talk with other people about them because I felt very sad facing all of those and being depressed by myself. But I'm joking. I'm joking. Honestly, like it's awesome problems to work on, and like it's great. Like we have a great team at Aikido. By the way, we're looking for more people if you want to join Aikido. And yeah, like overall, like these are awesome problems. We're basically being able to give value by finding more issues to real companies, and like now there's like a lot of pentests going on that are fully automated. So it's just great to see that what you're building is like better than whatever was being done before. You secure them more, and there's actually a lot of users that are happy about this, right? And seeing like all of these messages, like we love like find the critical after 20 minutes. That's awesome. Like it's always great to see those messages, you know.
Definitely, yeah, yeah. Exciting time to be working in.
Yeah, yeah. But
Cool.
yeah,
I'll link your Twitter account and things below.
awesome. Thank you. And
Thanks
yeah,
for
thanks again for the invitation. That's great. That's great chat.